In this scenario, we are going through a simple example of debugging a small 4GL program with the following elements: built-in and custom variables of different data types and scopes, 3 program blocks, the menu block and 2 functions, menu dialog statement, dialog style message box. In our case, we will use the FGL winMessage function, case statement, for loop. We are going to set normal breakpoints, set conditional breakpoints using the hit count expression, use variable expressions, use variables with the onChange condition. We will also inspect program state variables, 4GL built-in variables like int flag, change variable values in the debugger child program, launched using the run statement, and use the debug console. We start by setting a breakpoint for the main function block by clicking the leftmost column of the editor view. The red circle appears, denoting a breakpoint. Then, using the FGL Project Explorer, we right-click the program and select the Debug as Web Application option. Let's move the tab to another browser window to observe both the client-side browser and the server program. The program has been suspended with an indicator around the breakpoint. It is now paused on the function entry. In the sidebar, there are several auxiliary areas. The first one is the Variables panel, organized by the variable scopes, global, modular, and local. In the global one, for instance, there are built-in variables to query the state of the application, like the int flag or Querix last exception. The next one is the watch panel, where you can add expressions. Then, there's a call stack panel, which shows the functions and programs in order of how they're called in the stack. And then there's a breakpoints panel, that stores the list of all the breakpoints you have in your program. At the top of your editor in debug mode, there's a navigation bar, which you can move around by dragging. Its first button denotes the continue action, which will resume the program until it hits the next breakpoint. The second button is step over, useful when you've hit the line with a function call and don't want to step into the function. The next button is called step into, which helps to step into functions. The step out button helps to leave the current function. Pressing the restart button will restart the debugging process, and the stop button will terminate both the debugger and the program. Now we're going to set a breakpoint on line 61, containing a function call, by clicking the leftmost column in the editor. We click step into to demonstrate how the debugger interacts with the program. Here, in line 42, we are going to modify the global records member GLint. We can observe it in the variables panel. The value is null at the moment. We click the step into button once more to go to the next line, and the variable's value changes to 1. As we move forward, the values change accordingly, and the variables panel reflects those changes. Let's change the value dynamically for the variable in line 51. After the program has gone through the value assignment, the value is 1000. With debugger functionality, we can change it to any other value. Now we will press continue for the program to continue until it hits the next breakpoint, which is now on the call of the function named myLoops. Let's step into that function. The debugger moves us to the function, which contains loops. Here, we will demonstrate conditional breakpoints. The first one is the hit count expression so that when the loop had its third iteration, the program run would break. We place a breakpoint within the loop by clicking the leftmost column, then right-click the very same spot and select the Edit Breakpoint option. From the drop-down list with the break conditions that appear, we select the hit count one, and in the field beside that drop-down list, we specify the number of iterations and press enter. In the next loop, we set a breakpoint, but this time we specify the expression to break on, I greater than 3. Then we're going to add one more break. We can right-click the Global Records GLint member, and select the Add to Watch option, for the watch panel to display the value of an expression in the program's current state. In the Variables panel, we right-click the value and select the Break on Value Change option. If this value changes, the program run will be suspended. Next, we click the Continue button of the Debug toolbar. The debugger stops at the first loop, and the panels in the sidebar provide the information about the variables. We click the Continue button, and the next stop appears on the condition of I greater than 3, which we can also observe as a pop-up hint when we hover over the variable. With the next click of the Continue button, the variable's value is 5. As we click Continue again, the program stops at the last condition fulfilled, at the GLint record member change. In the Breakpoints panel, you can disable a breakpoint without deleting it by unticking its box. Once we have disabled the breakpoint, we click Continue. The program shows the message box. Note that when there's a dialog box active in the program, the debugger has no control over the program as it is the client-side functionality. You cannot query the program variables from the debugger's sidebar, and no program state is displayed. In this situation, we click the Pause button in the Debugger toolbar and proceed with the dialog, and as soon as the dialog returns control to the server-side program, the debugger is stopped. The pointer is now at the line where the message box functions code is. We click Continue, and now we're in the menu statement. Next, we click Pause and then run the child program from the main programs toolbar. Now the debugger is on the menu statement. Let's step into it. The pointer is on the line with the menu choice variable. We click Step into once more, and now the debugger is on the run statement. With one more click of the Step into button, we're in the child program, Debug Tutorial Run. Now we can observe the stack panel. It shows the debug tutorial program, the main one, and the program we're in now, Debug Tutorial Run. We select it and click the Pause button. Then, we go to our program's dialog and click the OK button. Now we're in the source code of our child program, more specifically, in the main function. If we click the Step into button, the debugger will stop on the loop. We click Continue, and the child program is called. Let's pause, click OK in the program's dialog, and click Step into afterward. After that, the debugger returns to the main program. Next, we are going to call a function with a very long loop to simulate a situation when the program is doing something and should have finished by a certain moment, but it hasn't finished and there's a need to find out why. When we click the button that calls that function, nothing happens in the window with the program running. Let's pause the program, and observe where is the program now. We can hover over the variables and get the values. Variable C is now on the iteration of about 120,000. Additionally, we can investigate using the debugger panes in the sidebar. Let's click Continue for the loop execution to resume. Those are the basics of working with Lycia Debugger. It also has one more awesome trait, the possibility of attaching the debugger to a remote process and performing the debugging remotely. Commonly, it is used for deployed applications, when the development seat is on an instance different from the production or testing server. Thank you for watching, and please feel free to contact us regarding any questions.